Flammability reduction is part of the Boeing Company's ongoing commitment to enhancing fuel tank safety. The system consists of a modified center fuel tank vent system and the nitrogen generation system, or NGS.
This program will familiarize you with the operation of the NGS installed on the Boeing 737. It will also show you the location of major components. The airplane, as shown, represents later model 737s. There are minor differences in the design and component locations for early model 737s.
The system overview will include major subsystems and how they work together, system control, operating modes, and automatic shutdown features. Next, we will look at component locations system by system following system flow. Then we will discuss NGS safety-related items, including working around nitrogen-enriched air, or NEA, fuel tank entry procedures, pack bay access procedures, and the location of NGS-related hazard placards and stencils.
Finally, we'll see common maintenance items including operability indications, system deactivation, drain inspection, and Byte Display Unit, or BDU, operation.
Before we get started, remember, this program is for training purposes only. For more complete and up-to-date information, always be sure to see the Airplane Maintenance Manual. The nitrogen generation system replaces the empty space at the top of the center wing fuel tank with nitrogen-enriched air, or NEA. This reduces the flammability of the tank because NEA contains much less oxygen than regular air. But where does that NEA come from? Bleed air from the engines enters the system through the NGS shutoff valve. The NGS shutoff valve also regulates the pressure of the air to prevent overpressure to the rest of the system. Next, an ozone converter reduces the level of ozone in the bleed air by converting it to oxygen. This is important because high ozone content could damage other components in the system. From there, the bleed air goes to an air-to-air heat exchanger, where it is cooled by air extracted from the left ram air system. The flow of the cooling air is regulated by the NGS ram air valve, which is controlled by the NGS controller using inputs from a temperature sensor. From the heat exchanger, the cooling air is vented overboard, while the cooled bleed air continues to a filter, which removes liquid and particulate contamination. After the filter, the conditioned bleed air passes through an over-temperature shutoff valve. This valve is controlled by the NGS controller using inputs from a temperature sensor. A thermal switch, which operates independently of the NGS controller, can close the over-temperature shutoff valve, providing backup protection for the air separation unit, which comes next. The air separation unit contains an air separation module, or ASM, which extracts oxygen from the air to create oxygen-enriched air, or OEA, and nitrogen-enriched air, or NEA. The OEA is dumped overboard. Finally, the NEA flows through the high flow valve to the NEA distribution system, or NEADS, which delivers the NEA to the center fuel tank. All of this is controlled by the NGS control system.
The NGS controller opens and closes the high flow valve to control the flow of NEA according to 3 delivery schedules, depending on the phase of flight: off, low, or high. On the ground prior to flight, the NGS is off. During normal operations for climb and cruise, the delivery schedule is low.
For descent, the schedule is high.
And upon landing, the NGS system will continue to operate through taxi for a short period of time, provided bleed pressure is available, and then the system will shut down. Other non-normal events or failure conditions will also cause automatic shutdown of the system. These are NGS overtemperature, cargo fire alarm, or an engine shutdown in flight.
Now that we've seen how the nitrogen generation system works, let's see the locations of the main components.
Note, this video was shot on various airplanes in various stages of manufacture. Insulation may or may not have been installed, and in some cases the orange flight test wiring may still be seen.
Most of the components of the NGS are in the left ram air duct compartment or the left air conditioning pack bay. Open the left ram fairing panel and the air conditioning access door to get to these components. Note that throughout this program, when we remove a panel or open a door, some of the fasteners may have already been released to save time. The NGS shutoff valve is attached to the bleed air duct in the forward part of the left pack bay. The ozone converter is just aft of the NGS shutoff valve. Then the air supply duct leads outboard to the ram air duct compartment and aft to the heat exchanger. The NGS ram air valve is between the heat exchanger and the ram air exhaust duct. Next is the filter. Then the air supply duct leads aft, outboard, and then forward again to the temperature sensor. Let's move up for a closer look. And then to the thermal switch. Then to the over-temperature shutoff valve. And the air separation module. Note the inlet to the air separation module is at its aft end, and the outlet is at the forward end. Next is the high flow valve.
The high flow valve has a delta P sensor that verifies proper operation. You can't see it here, but a line from the back of the high flow valve goes to the oxygen sensor. The oxygen, or O2 sensor, is forward of the ASM assembly, inboard of the ram air duct. The O2 sensor samples the amount of oxygen in the NEA and sends a signal to the NGS controller for monitoring and indication. We'll talk more about that later. From the high flow valve, the 𝐷𝐴DS line bends around and runs aft to a backflow check valve. The backflow check valve prevents fuel from flowing back into the NGS system. Looking at it from a lower angle, we can see that just ahead of the valve is a tube that goes to the GSE port. And just aft of the valve is a T-fitting with a cap for use in the leak check. Note, instead of the T-fitting, some models have a hose leading to a drain valve, and on other models, the hose is attached at a different point. See your maintenance manual for exact information for your airplane.
From there, the 𝐷𝐴DS line continues aft and penetrates into the left main landing gear wheel well. Then goes up the forward wall of the wheel well and penetrates the rear spar into the fuel tank. The rest of the 𝐷𝐴DS components are inside the fuel tanks and will not be shown in this program. Moving to the right wheel well, we find the operability indicator on the aft side. Next, we'll open the right pack bay access door and the ground pneumatic connector access door. The built-in test equipment display unit, also known as the byte display unit or BDU, is in the forward right pack bay, next to the ground pneumatic connector. The NGS controller uses the BDU for system interface. The BDU has several main functions that include ground tests, existing fault data, and fault history data. NGS fault messages only show on the BDU. And finally, the NGS controller is in the ECS mix bay. Between the aft end of the forward cargo bay and the front spar. Now let's take a few moments to talk about safety. In most cases, nitrogen is absolutely harmless. After all, the air we breathe is mostly nitrogen. But remember, the NGS creates nitrogen-enriched air by removing oxygen. If a person breathes air with low oxygen content, it can have dangerous and immediate health effects. NEA will collect in the fuel tanks as part of normal operation, so failure to obey the precautions described by the NGS danger placards and stencils will cause serious injury or death. And NEA may collect in the left ram air compartment, the left AC pack bay, or the main landing gear wheel wells under certain failure conditions. So the caution placards in these areas direct you to your company's safety procedures to avoid possible injury. These hazard placards or stencils are near the access for the fuel tanks, left AC pack bay, the left ram air compartment, and the main landing gear wheel wells. Also, note the NGS system components can become very hot during operation. Be careful to avoid damage to other equipment or injury to people. Now that we've seen how the system works, the location of the major components, and discussed safety, let's take a look at some common service and maintenance items. NGS status shows on the operability indicator in the right wheel well. If the green or upper light shows, there are no faults detected and the system is fully operable. If the blue or middle light shows, the system is operating in degraded performance mode, but no maintenance action is required for MEL dispatch. If the amber or lower light shows, there is an NGS system fault. And if there is no light showing, the NGS system is inoperative. Note that if the amber light is showing, or if no light is showing, maintenance action to deactivate the NGS system is required before MEL dispatch. Now let's look at some common maintenance tasks. Note, we are only going to see enough of the following procedures for general familiarization. For example, there are other tasks you must do before closing the NGS shutoff valve to deactivate the system. Remember to see Chapter 47 of the Maintenance Manual for more information before beginning any NGS maintenance task. As we saw earlier, the NGS shutoff valve is in the left air conditioning pack bay. Make sure the NGS shutoff valve is in the closed position and align the hole in the arm with the threaded boss on the valve. Remove the manual lock bolt from the valve body and install it through the hole in the lock arm. Finally, be sure to follow your company's MEL procedures for notifying air crews and other personnel that the system is inoperative.
Now let's take a look at the fuel leak check for the NEA distribution system. The air separation module can be damaged by fuel, so you must check for evidence of fuel leakage at the specified intervals. The example we'll see uses one of the drain valve configurations. The process is similar for airplanes with the drain cap near the backflow check valve. See the airplane maintenance manual for more information. The drain valve for the NEA distribution system is in the left pack bay or in the ram compartment, depending on the model.
Put a container below the drain valve. Then press the drain valve. If any fluid comes out, there may be a leak in the NEADS line. See Maintenance Manual Chapter 47. You must also periodically inspect the cross-vent check valve in the right surge tank. You access this at the right wingtip. Refer to the manuals for more information on how to complete this task.
Finally, let's take a look at BDU operation. Turn on the BDU by pressing the on-off key. This brings up the first item in the top-level menu, Existing Faults. The Existing Faults menu shows the fault maintenance messages that are present in the system. With these, you can look in the Airplane Maintenance Manual to find more data about the system problem, specific LRU information, and how to clear the fault. You can cycle through a menu using the arrow keys. Pressing the down arrow key brings up the next item, Fault History. Fault history shows the details of previous faults that are in memory and specific information on when the faults occurred. Press the down arrow key again to get to ground tests. This item allows you to perform a series of tests on the nitrogen generation system. Finally, press the down arrow key one more time to get to the last item, Other Functions. This item can give specific information regarding the controller and airplane configuration. Let's press the up arrow key to go back and take a closer look at ground tests. Select the Ground Tests submenu by pressing Yes. The first item in the Ground Tests submenu, Electrical Test, performs a quick system test of various components and sensors that interface with the NGS controller. Now we can use the arrow keys to cycle through the Ground Tests submenu. Pressing the down arrow takes us to System Test, which will run an operational test of hardware and will operate the system in low and high flow. Note, bleed pressure is required to run this test. Next is the NGS Performance Low Flow Test. Then the NGS Performance High Flow Test. You will also need bleed pressure for these tests. And last is the Display Test. Let's use the up arrow to get back to the Electrical Test. You run a test by pressing the Yes key. In this example, the electrical test begins and the test in progress message shows along with the % complete. When the test is complete, the test result message shows. In this case, we passed. To go back to the menu, we press the menu key. And to go back up to the top level menu, we press the menu key again. To turn off the BDU, press the on-off button and a message will show asking you to confirm that that's what you want to do. Press No to go back to the menu, or press Yes and the BDU will turn off. If you don't press either key, the BDU will shut off automatically after 5 minutes.
This ends our program, 737NG Nitrogen Generation System Overview and Component Locations. We have seen how the Nitrogen Generation System, or NGS, cools and conditions bleed air from the engines, separates it into oxygen-enriched air, or OEA, and nitrogen-enriched air, or NEA. Then distributes the NEA to the center wing fuel tank. We saw how the NGS control system controls operation for performance and safety, and how to get status information. Then we saw the location of the major components. Next we learned about safety and the NGS. Remember, breathing nitrogen-enriched air can be harmful or even fatal because it does not contain enough oxygen. NEA will collect in the fuel tanks as a part of normal operation and might collect in the left AC bay, the ram air compartment, and the main landing gear wheel wells under certain failure conditions. Also, the NGS components become very hot during operation. Be careful to take all required safety precautions.
Finally, we saw how to deactivate the NGS for dispatch or maintenance, how to check the NEA distribution system for fuel leaks, where to inspect the cross-vent check valve, and the basics of how to operate the BDU.
One last reminder. Always remember to see the Airplane Maintenance Manual, other Boeing documents, your own company's procedures, and any related regulatory agency documents for complete, updated information.